This question can initially feel a little bit strange because it's got this word frustum in it, and you may or may not have seen this before in class, but what you need to be thinking about with this is the fact that if it is an unusual word, it's probably got a definition for it in the question, and it does. It says it's formed by removing a small pyramid from a large pyramid. And it's shown in the diagram as well. So you can sort of see what's going on over here. It was a big large pyramid like this. It's had the top bit of the pyramid removed, which has just left this section underneath. So pretty much all of our information that we're going to need for this question is on the diagram itself. So we know that it's 120 centimetres tall as its perpendicular height. We also know that it's 60 centimetres at the bottom and 60 centimetres in the other direction as well. So we know it's a square-based pyramid. And we can see that the part of the pyramid that's been removed, the base of that is 45 centimetres. So lots of information that we can use. Finally, we're asked to find the volume for the base. So the volume for the grey bit that you can see there. The last bit in the question just says to give your answers in litres, so perhaps if we do this in centimetres cubed to start, we're going to have to convert it into litres at the end. You don't get given the formula for the volume of a pyramid itself. However, what you might want to think about is the fact that you are given the formula for the volume of a cone, and you can see that this shape and a cone are quite similar. The only difference is that the cone has a circular base and the pyramid has a square base. So you can convert that cone formula. So the cone is given by, so V cone is 1/3 pi r squared h. So if you just replace the bit which is about a circle, which is this section here, replace that with a square, then you're going to be absolutely fine. So the volume of a pyramid equals 1/3, and then we'll call it base squared times height. So relatively straightforward there. Okay, so we'll substitute in the numbers, and at the moment I'm just going to do it for the original pyramid before anything was cut off. So I'm going to call this V large, just to make sure I'm clear about which one I'm using at the moment, and it's going to be 1/3 times 60 squared times the main height, which is 120. So popping all that into the calculator gives us 144,000 centimetres cubed. Okay, so now theory says that we should be able to work out the volume of the bit that's been removed, and then we can subtract that from the figure of the large one that we've just worked out. Now the only problem we've got at the moment is that we don't know the height here of the small pyramid. We know the base, that's 45, but we don't know this height. Because it's the same pyramid, we could use similar shapes facts, okay? So we already know that the base is 45 compared to 60 for the small pyramid. So you can see there that it's 45 over 60, or 3/4 of the height size. So if this is 3/4 of that, then this height must also be 3/4 of that height. 3/4 of 120 is going to be 90. So maybe let's use that. So now we're going to do V small is 1/3 times 45 squared times 90. Okay, so there's a little aside here. It's 3/4 of 120. And that's going to give us 60,750 centimetres cubed. So to complete the question, we're going to do the volume of the frustum, and we can calculate that by doing 144,000 minus 60,750, and that's going to give us our final volume, which the question asks about. The only next step for us to look at is to find what the volume is in litres. So for this, you're expected to know the conversion between centimetres cubed and litres, and that happens to be 1,000 centimetres cubed equaling a litre. So if we just shrink our work very slightly, then we can do the final bit of the calculation, which is that the volume in litres is going to be 83,250 divided by 1,000, which is 83.25 litres.